Hey guys again. So last time we started the last video, we did factor by grouping. We did examples. We did U tripart, and there was a Khan Academy assignment that I'm gonna check later this week. But for now, I'm gonna finish or try to finish and factoring, and we're gonna be talking about how to factor difference of perfect squares. Again, we did this in class, but I just like to go over it with you. How to factor difference of perfect squares. So again, when you think of the word perfect square, the first thing you think of is two same numbers you will multiply together that will give you the answer. So let's say we got 4 times 4 is 16. So 4 square equals 16. So your perfect square is 16 is a perfect square. So we're going to take example. Let's see. Last time we had example 4. Now we have example 5. And it's going to be 81 minus 16x squared. One of the very important points you have to keep an eye on is that it has to be the difference. It has to be the difference. And you know the word difference means subtraction or minus. So, and then the second thing I'm going to think of is this a perfect square? Is this the whole term has to be, is this a perfect square? And here I have difference, and here I have a perfect square. So I have a difference of perfect squares, which means I'm going to be able to factor this in 2 easy steps. All right. Now, since this is a perfect square, I don't want to think of taking any greatest common factors, because if they are imperfect squares, it's easier for me to find their factors. So I know that 81 is 9 times 9, which is 9 squared. I know that 16 is 4 times 4, which is 4 squared. And we know that x squared is x times x. So both of them are multiplied twice. So that's how we know these are perfect squares. Now I'm going to rewrite the question again. And we got 81 minus 16x squared. So this would be 9 minus, we're going to take one of the 4's and one of the x's, 4x. Now we're talking about factors, which means I'm going to have 2 parentheses next to each other. That's what factor means. It could be more than 2, of course, more than 2 parentheses. But in this case, we're going to have only 2 parentheses. One of them is going to be 9 minus 4x. The other one is going to be 9 plus 4x. And as you remember in class, we did expand this to prove that when we expand it, we're still going to get 81 minus 16x squared. So this is your answer. Simple. Difference of perfect squares is actually one of my favorites. So if you guys have any questions, please email me or text me or send a message on Google Classroom. Just make sure you guys stay connected. Do not move on to a new lesson if you do not have, that lesson really well understood. All right, so I'm going to give you example 6. And of course, this is the U tripart. And I would really suggest that you pause the video for like 1 minute or so. And then you can come back and check your answer with me. So again, I'm going to think, do I have a perfect square here? Are there two numbers I'm going to multiply that will give me same two numbers I'm going to multiply that would give me 25? Yes, which is 5. Is that a difference in here? Yes, it's minus. Does it work if I have a plus here? No, it will not. So do I have a perfect square in here? Yes, I got 4, which is 2 times 2, and I got x squared, which is x times x. So my answer is going to be 5 minus 2x. So I did the negative. Now it's time for me to do the positive. And ta-da!
That's it.
That's it. I'm done. I know, that's why I said I like this. It's really one of the easy and fun ones. And you know, on the SAT, you will always see questions that have a difference of perfect squares. All right, I'm gonna do example 7, and I'm gonna still continue working with these kind of questions. It's gonna be a little bit different, and that would be example 7. 36 x to the 4th power minus z squared. So the first thing I probably would look at is the difference. Okay, I have a minus. Now let me see if the terms are perfect squares. I know that 36 is 6 times 6, which is 6 squared, which is a perfect square. Now let me think of x4. I want to make this into a square because, as you know, we are talking about perfect square, right? So what do you think x to the 4th power is going to be?
X squared.
Times.
X squared.
So x squared times x squared, right?
Can you do x squared squared? Is that a thing?
You mean x squared all squared? Yeah, that is a term. So that is a perfect square. Now let me see the z squared, which is z times z. So my terms are going to be 6, x squared, and z. This is what I'm actually going to use to find the factor. 36x4 minus z squared. So we agreed that this will be, I'm going to use my pink, 6x squared, I'm going to drop this down, minus the z squared, we agreed that it's going to be z, and then we're going to open parentheses, the other one has to be positive. And then this is going to be my answer, 6x squared minus z into 6x squared plus z. Yep, it's that simple. Now, I'd like to do example 8, and it's going to be the U tripart. And then after that, I'm going to move on to the diamond method or the X method, whatever you guys want to call it. But I know you guys like that method when we factor quadratic functions using the diamond method. All right, then the U tripart. I'm going to go with 16x to the 4th, y to the 4th, minus 64. So, as I always say, I suggest you guys pause the video before you move on. I also like to break this down for you guys. 16, I'm gonna look, yes, I do have a minus, and all of these are perfect squares. Let's prove that. So 16 is 4 times 4, so which means I am using, just looking for my highlighter, oh, it's right here, which means I'm using this as a factor. All right, let's see x to the 4th power, which is x squared times x squared. If you're not sure how to do this, here's what I would suggest. I would suggest you do x squared, x to the 4th is x times x times x times x 4 times. And I would like to group them in groups of 2. So that would be x to the 2nd power times x to the 2nd power. So that's x to the 4th power is equivalent to this. All right, so that would make it a perfect square. But the factor that I'm going to use is going to be x to the 2nd power. Now let's go ahead and check the y to the 4th power. And I'm going to actually break it down. And y to the 4th power is going to be y times y times y times y. So since I'm looking for perfect squares, the word square means we need to group them in groups of 2. So here I got y squared times y squared. And this is y to the 4th. And the factor that we're using is going to be that y squared. Now we got one more term, which is the 64. And we know the 64 is a perfect square, and it's 8 times 8. So this is my factor. So I'm going to go ahead, and I don't want to flip it on a new page. I'm just going to write it here. 16x 4th y to the 4th minus 64. Now we get the factor for each one of the terms. I'm just going to sub them back in. It's going to be 4 times x squared times y squared minus 8. Remember, the other factor is going to be the exact same one, but it's going to be with a plus instead of the minus. And here is your answer. And that was the end of how to factor a difference of perfect squares. I'm going to have Khan Academy assignment assigned for you. Please make sure you text me or call me, send me an email, or send a message on Google Classroom if you have any questions, and keep practicing. And next we will have another video on how to factor quadratic functions using the diamond method or the X method.